Introduction to FPGA technology, devices, tools, and its applications. Now here is the contents list. Firstly, we have historical overview, the technology which is evolved into this FPGA, which contains PLDs initially, then the devices which are FPGA and ASICs, which are going alongside in comparison with each other and doing some good competition for high and low volume applications. I will tell you what are high and low volume applications later in this presentation. Then we will look at the FPGA architectural overview, Xilinx Spartan 3 overview, which is associated to Xilinx, which is creator of the FPGA, and then later FPGA tools which are used in developing the applications over this semiconductor chip, and finally FPGA applications. Now, taking an historical overview, as we all know what an FPGA is, it is a device consisted of arrays of different gates with memory blocks and clocks inside. These components vary according to the version we are using, plus the type of FPGA we are undertaking for our study or developing any kind of application. These arrays are programmable, which makes it a very flexible device to be used in almost every application, which includes signal processing and general purpose operations or control operations in it. Okay, now as a historical overview, I would like to tell you that digital circuits, as we all know, give us a finite set of values, whereas analog electronics contains a huge bunch of values over a single graphical line. And for electrical point of view, it is good as well to have lesser values for selection than a bunch of values on a curve of a graph. As we all know, if we have a smaller selection of values, then it will be easier for us to choose and pick the value for anything. And in most cases, since we have only two states in digital electronics, 0 and 1, so it becomes pretty easier for us to assign particular values in particular conditions with respect to certain voltage levels. Now here is a brief overview of the historical development of what we call modern day digital world. Talking about historical overview, I will not tell you headings in this introduction, just will go through them step by step, and the purpose is to tell you how it is evolved simply. Introduction of fabrication technology brought revolution in digital electronics, which gave us the first surprise in the form of TTL ICs. TTL is commonly abbreviated for transistor logic. The first series came to market was 74 and then 54 IC series. These are the most famous in TTL series, where basic gates were fabricated over the series like AND gate, OR gate, and NOT gate. Advancements in this technology brought further progress in the form of CMOS, complementary metal oxide semiconductor technology. The difference in both technologies is with respect to their power consumption, where TTL consumes more power and CMOS consumes less. TTL logic is based on BJTs, where CMOS comprise of FETs. As we all know what are BJTs, if you have studied analog circuitry or analog circuit analysis in your courses, then you would know BJT is bipolar junction transistor, which is most used in most analog circuits and for interfacing purpose as well, whereas FETs are field effect transistors. Now the difference between these two technologies is that TTLs were more faster, they were more fast in switching applications than CMOS. Although CMOS contained less power earlier, but because the switching speed of the CMOS lesser than TTL, TTL were preferred for so long over CMOS. But now as the technology has evolved, CMOS are almost equivalent to TTL in its switching speed as well. So as you know, if we buy any product from the market, then companies like to mention it, especially on their product manual, that it is from CMOS technology, which makes it a preferable device, because CMOS is most better in TTL in many cases. For example, power consumption, which is most critical in all, plus the switching speed as well and their reliability. Secondly, after these ICs were developed and huge amount of transistors were being fabricated, it was thought of developing such circuits which could be programmed as well. As we all know, the development in the digital circuits brought a flood of circuits being fabricated over small chips. Like now we have millions and trillions of transistors over single microprocessor chips. And as we know that by using fundamental gate logics we can develop any logic from combinational to sequential. So by using these fundamental logic gate arrays, PLDs were created. Now after TTL and CMOS, PLDs were created. Now what a PLD is? PLD is basically a device which contains arrays of AND gates and OR gates. Now these arrays were developed in the sense of getting them programmable, so that we could create the logic of our own choice rather than have vendor specific logic which cannot be modified later. Further improvement in technology brought CPLDs into the market, which is complex PLDs, complex programmable logic devices, and finally FPGAs made their way into their fast growing digital world. These FPGA initially came as competitors to CPLDs. Now the word of integrated circuits. Currently in the world of integrated circuit we have most common application in the form of mobile phones or other MPG4 MP3 devices which are used at a huge level, iPods, etc. And now the latest thing which came to market by Apple Industries is iPad. Now these gadgets contain mostly ASICs in them. ASIC is an application specific integrated circuit. Now there are two types of ASIC which come into market: full custom ASIC and semi-custom ASIC. Whereas another integrated circuit form is user programmable, which comprise of PLD and FPGA. PLD stands for programmable logic device, and FPGA, as we all know, field programmable gate arrays. Now we have ASIC and FPGA going hand to hand, competing with each other in the fast growing world of digital electronics. And ASIC is little older than FPGA because it has been developed and fabricated for especially for mobile applications, where we have high and low volume applications, and especially we need by the time high and low volume applications. What are high and low volume application is basically any application which is developed by latest tools, which contains latest and most modern features in it. It is known as high end device. And low volume, as we all know, which contains most less space in it. Now there are differences in ASIC and FPGA. Normally ASIC is preferred for mobile applications. Since FPGAs are new to market, there is not much research over it, and for mobile application ASIC has been fabricated for long time. But still, the way FPGA has been growing and it is created, it is preferred over ASIC in much larger extent. Now I have two things to discuss about ASIC and FPGA. Firstly, as the name suggests, ASIC is application specific, whereas FPGA is very flexible. It can do multiple things at a time, whereas ASIC can perform tasks which are specifically assigned to it. These are very expensive as compared to FPGA because the design must be sent for expensive and time consuming fabrication in semiconductor foundry, from the design idea to the actual implementation. This is a problem with ASIC because in FPGA there is nothing like that, and designs all the way from behavioral description to physical layout, they are done in semiconductor foundry, and it costs them very much. Specifically, if we see, ASIC costs much in non-recurring engineering. Non-recurring engineering, what is it? It is a process normally carried out by companies which manufacture ASICs. This process takes money, human effort, and machinery much more than an FPGA takes. Now, FPGA, field programmable gateway, small development overhead, not much like ASIC. No non-recurring engineering cost. NRE, non-recurring engineering. Quick time to market, they come into market very quickly with compared to ASIC where they take too much time before coming to market. And no minimum quantity order for business point of view. If you want to have a specific type of ASIC, then you will have to order a minimum quantity at least. And FPGA is reprogrammable. You can reprogram it again and again and again, whereas ASIC is fixed. And in other advantages of FPGA, manufacturing cycle for ASIC is very costly, whereas for FPGA it is not very lengthy and engages less manpower, whereas ASIC contains a huge amount of manpower. In ASIC development, mistakes normally detected at the end of the design level are normally not correctable, whereas in FPGA you can correct any problem at any stage of development. And for rapid prototyping of digital circuits or any kind of test equipment, FPGAs are very best. Easy upgrades like in case of softwares, unique applications, reconfigurable computing, etc., etc.